Okay, hi everyone, good evening. So, yeah, there were I think 3 day break between my last what we say day on DSA and now things came up and yeah, so the consistency broke a little bit. Anyways, we will like start DSA again. So this will be I'm skipping those 2 days and this will be my DSA day 6. Uh, so let's start with the strings today, right? So let's go through the like text, what it says, what all things they mention. We may Google search anything if like we don't know. So like this is the explore section, by the way. You can come here. Okay, so introduction to string. A string is actually an array of Unicode characters. You can perform almost all operations we used in an array. You can try it out by yourself. However, there are some differences in this article. We'll go through some of them. You should be aware when dealing with a string. These features might vary from a lot from one language to another. So we are right now using Java. Let's say okay, this is in C++. I also know about C++, but yeah, I'm more comfortable in Java. Okay, so we compare function. String has its own compare function. We'll show the usage of compare function below. Here there's a problem. Can you compare? It depends on the answer to the question. Does the language support operator overloading? The answer is yes. We may use equal to compare to string. We use it. If the answer is no, we may not use equal to compare two strings. It actually compare with okay, yeah. So I actually know a little bit about this concept. So in Java, everything is an object, right? Weird. In Java, everything is a object. So obviously, when it tries to compare one string with another string, those are two separate objects, and they can never be equal, right? They can be like if the object implements a comparator and then we compare. I think then it may be equal. Not sure. I don't think so. One second. Can to objects in Java be equal if they implement comparator? Comparison meant to check equality. Count does not return boolean, so this cannot be how to write if two objects are equal. Custom compare level says okay, already a -4 downloads. Must be a dumb question to ask. Anyways, so consider that you can use equals. Comparison meant to check this equality. Comparator does not return boolean, so this cannot be used. If you're looking for it to check any two objects are equal, then the standard you do is override object dot equals in their respective classes. Then you simply call x dot equals y. Okay, object dot equals. I'm interested to know like what goes under the hood in object dot equal. Let's take under the hood. Let's take a look, right? So we'll come to the questions later. I will do this. Yeah. So let's take look under the hood. Let's take on look under the hood. Okay. So okay, I this was my from my previous design pattern session today. So if you haven't watched that, you can go and watch that live stream. So let's say that we have a test car, right? We create a new test car with exactly the same parameter test car 2. And if I say objects dot equals test car and test car 2, right? So let's say what it returns. So what it says equals is ignored. Yeah. System. False. So these two objects are not equal, right? But what if I go to my car? What's the test car, right? And I override equals method, right? So if I override equals method, we can, okay, just say if return super dot equals object. So we'll check what super is doing. Return if, like, return obj dot equals one second, obj dot, so my, I think obviously when we are comparing with equals, when my object, like, we can place some checks. So if obj sense of car, then only we'll provide, otherwise we will just say return false, right? Now if obj instance of car, then we will say obj dot engine dot equals this dot engine, right? This dot engine first is end end, just return this. Engine and gear, we will only compare engine and gear, right? Gear is a int, so equal to this dot gears. Okay, so if these two properties are matching, then I will say that object is equal. So let's try now. Still false, weird. Return if a equal to b, a not equal to null, a dot equals to, but we have overdone this here, right? Ah, I get it now. I can actually say test car dot equals test car 2. Right, now it will work. It's still not working. Test car dot equals test car 2. Why do test car, because these two strings are different, right? Because, okay, it's just a string test which is equal to test car. Let's validate this theory. Actually, yeah, I got the point, because the engine, okay, engine is different, right? Engine, standard engine, which is equal to new standard engine. Now if because each time I'm creating a new object, right? So actually one second, I think what I need to do is, in my equals method, where's my test car, I, rather than checking this, I'll just say type dot equals this dot engine dot type, because now the engine type is same, right? So standard engine type is always standard. Okay, now let me just check. Okay, now these two objects are equal, right? But what if I never had this? Then it would be false. So let's see that what super is doing, right? So let's see if what super is doing. Not this Superman. One second, there was some super here, na? Super dot equals. What it is doing? So indicates whether some other object is equal to this one. The equals method implements an equivalence relation on non-null object references. If it is reflexive for any non-null interface value, x dot equals x should return true. It is symmetric for any non-null preference value, x should return true. It is only if y dot equals return true. It is transitive non. It's consistent. Okay, I don't understand here what it is trying to say. Let me put that into let me put that into chat GPT and see what it is doing. Yeah, give me a moment. Let me set up the chat GPT. Just give me a moment, guy. Setting up the. I've not signed up for ChatGPT. One second. Okay, so oh, okay, okay, 1 second. Yeah, let's put this in ChatGPT. Say, can you explain this to me? It's a documentation Java object equals method. As when the contract equals method, the equals method is used to compare two. Okay, should always return true. In other words, an object should be equal to itself. Ah, reflexive. What in another should return true. Symmetric. If it's true, then y equal should also be true. It's. I think it's just reading the documentation, right? If x equals is true and y equals x, should acha. Okay, so okay, yeah, makes sense. What was written here? Ah, they have shortened it out. Transitive. If x equals y is true and y equals z is true, then x equals z. Yeah. Okay. So these all are properties of what we read in reflexive, symmetric, transitive. These all are properties of function. No. If we check it, if we say uh, maths functions properties transitive, reflexive, and all that. I think these are all. Yeah, these are reflective, real number properties. Symmetric, the present all real numbers x and y fixed. So these are just the properties of like real numbers only, like reflexive, symmetric, transitive, consistent. Multiple no should. So that's provided handling null for any non-null reference x dot equals null return false, and these will correctly define the behavior that expect from the equals method according to the contract. Ensures that the equals method work predictably and consistently. Oh, I never knew this. So equals basically for follow these properties, right? So let's get back to my scene. Not this one. uh, yeah, this one. So an equivalence partition relation partitions the element it operates on into equivalence classes. All the members of an equivalence class are equal to each other. Members of an equivalence class are substitutable for each other, at least for some purposes. Params object, the reference object with which to compare returns true. So, okay. Return this equals. Weird. So what's this? This is my object class. Object has us. Oh, let me get back to ChatGPT. Okay, so how Java compares two objects? How is it different from comparator? In Java, comparing two objects method, which is part of the object class, the different equals method is object, the class compares memory. Okay, it compares the memory address of the object, essentially checking whether the two reference point to the exact same object in the memory. However, in many cases, you may want to define a custom way to compare objects based on their content, or this is where comparator interface comes into play. Yeah, this is a comparator interface only, no? So why over there? Comparator is not written well, so this cannot be used as. I don't know. I don't know what they were saying. I think here it is better, right? Yeah, this is what a comparator is, right? Using comparator. Yeah, this is the comparator, right? And this is the using equals method. Okay, in this example, the equals return a value of attribute to classes. Here, a custom comparator is defined to compare two my classes objects based on the value. This allows you to define values comparing object without modifying the class. Okay, so I now understand what Stack Overflow was saying, because it is an int, not a boolean, so you can't basically compare to object which returns in a like this will be greater, less, or equals, na? So makes sense. Now it makes sense. It's used for testing the interface, specifically for comparing objects in a custom way, allowing you to define criteria without modifying them. In summary, equals method is used for testing equality based on content, while comparator interfaces allows you to define custom comparison logic for objects that may be used for sorting or ordering a collection. Makes sense. Makes sense. So okay, yeah, makes sense. How in many cases you may want to do so it basically compares the memory addresses of the objects. That was my question initially was. Okay. Mm, okay, so yeah, spent a lot of time on there. Coming to next, immutable or mutable. Immutable means that you can't change the content of the string once it's initialized. In some languages, the string is mutable. That is to say, you can modify the string just like binary. In some like Java, the problems going on the next slide. Whether the string is testing the so your string mutable and not mutable. Basically, you can't change a string after making it, right? Essentially, in a string in C++, a string is an array, so you can change it, but like in here it's if I run it, what happens? String from yeah, so you can't change a string in Java. Essentially, once the memory addresses are defined, if I understand that way, if memory addresses are defined in Java, then you can't. Okay, so I don't understand why the string is. Okay, let's ask this to ChatGPT as well. Why why fundamentally the in string in C++ is mutable while in Java it is not. Design choices made by and these choices are driven by different considerations: thread safety, caching, code. Okay, so how can I make a string mutable in Java? In Java, string is a design. You may means that once a string its content can. However, if you need mutable string like behavior string classes, these classes provide a mutable sequence of characters. Okay. Why is that? The primary difference between them is string is not synchronized, make it more efficient in single time, while buffer is synchronized. Single for most users, single. Okay. Yeah, so we can say that it was choice by design, but we can use a string buffer or anything to mutate on the strings. Got it. Now, compared to any array, there are some extra operations we can perform on a string. Here are some examples. So a substring is there, and yeah, you should be aware of the times of these built-in operation. When if the length of the string is n, the time comes of both finding operation and substring operation is on. Also, in language which string is immutable, you should be careful with concatenation operation. We will explain. Okay, makes sense. Now, got to take time complexity of built-in operations into consideration when you compute the time complexity of your solution. Okay. You should know whether the string in your favor is immutable or not. If the string is immutable, it will bring some problems. Hopefully, we will also first. But yeah, if the string is immutable, I can basically use na string buffer or a string builder. Obviously, it cannot be. If you want to adjust it, you have to create a new string. Beware string original, you should let's look at example. So string is, and you are adding, so basically you are creating 10,000 instances of string, so it will, like, it's a lot. Notice how slow string continues. For the other hand, there is no performance impact in SQL in Java since the string is immutable. Concatenation works by first including enough space for new string copy. The yeah. Therefore, the is in total will be O of n square. Yeah, for n objects you are looping for n times, so yeah, it would be O of n square. So if you want your string to be mutable, there are some substitutions. If you did want your string to, you can convert it to a char array. Why would I do that? Yeah, so this, if you have to context strings over, it will be better to use some other data structure like string builder. The below code is on complexity. Yeah, because it is modifying the original instance. So let's see how the like string builder works. So internally, what the string builder does so that it can modify the strings. Maintains a buffer which is essentially a dynamically resizable array of characters. This buffer type capacity string builder has a initial if not larger. So it's basically an array, na? Why? String builder is basically an array. There's a simplified version value and capacity string open string ensure capacity get char set str dot what is str my to allow efficient string modification operations. Okay, let's come to the question straight. So given two binary strings a and b, return their sum as a binary string, a equal to 1 1, b equal to 1. So that would be 0 12, right? So 12 out of 0. Don't understand. Given two binary strings a and b and return their sum as a binary string. What is a binary string? Okay, makes sense. Oh, okay, so binary string is basically two based system, and for 1 1 we have 0 to the power 0, that is 1, plus 2 to the power 1 2, that makes it 2 plus 1 3. Okay, let's come to the pen and paper, right? That way we will better understand what's going on. I'm switching the screen. Yeah, I hope it's visible, right? So our question is add binary. Add binary. And we have a equal to 1 1, b equal to 1. So this would be 2 to the power 0, 2 to the power 1, this will be 2 to the power 0. So this will be 1 plus 2 plus 2, 2 3 4 5, 2 3 4 5. So it would be 5, right? And then I have to return it as a binary. So I have to say to return it as a binary, which means I have to represent it as 2 to the power 0 to the power 1, right, and 2 to the power 2 plus 4 plus 0. So yeah, 1 0 0, right? That's what makes it, because 2 to the 4 1, it would be 2 to the power 2 to the power 0, that would be 1. How to convert 5 into a binary expression? So I know it would be 1 0 0. Ah, my bad. 2 to the power 0. If will not it be 4? Let's check. 0 1 2. 0 2. 6. This would be 1, right? Because 2 to the power 1. No, 2 to the power 0 to 1. That's correct. 2 plus 1. 3 triple 0 is also 1. My bad. So it would be 2 to the power 0, which would be 1. That would not give me 5, that would give me 4. Now it makes sense because 2 to the power 2 would be 4 here. So yeah, so it would be 1 0 0, right? Otherwise it would have been something different. Okay, similarly if we look at another example, we have a equal to 1 0 1 0, b equal to 1 0 1 1. These are all string, right? So okay, no problem. We have, so this will be 2 2 3 2 to the power 3. 0 1 2 3 0 plus 2 to the power, so 8 plus 2 10 would be 2 over 3 plus 0 2 1 plus 8 plus 2 plus 1, which is 11, and adding both of these we will get 21, and then 21 we will, how will we represent 21? To the power 4 plus 2 for 8. Oh, sorry, my bad. 2 for 8 is 16 plus 16, 17, 18, 19, 28, 21. So 4 plus 1, right? So 4 plus 2 to the power 2 plus 2 to the power 0. So we will have 1 0 1 0 1, which makes sense. Okay, so I have thinking of a simple approach. What we can do is basically we take out each character, right, and then we multiply it by 2, get this. Same for this, we add both and we convert that back to binary. That's one approach. And what if I add these strings directly? So if I say 1 0 1 0 plus 1 0 1 1 to 1, we will be adding with the base 2, so 1 1 2, or 2 would be 1 0 be 1, this would be 1 0. Yeah, so if we directly add 1 1 1 1 1 1 0 1 1 1 0, great. So if you directly add these two strings, we'll get our answer. Like, we don't have to convert it here then convert it. There's a redundant effort, right? So what we are doing right now, addition and all, it is working in a base of 1, right? If I add both of these, I just need to reinvent the addition in a new base. तो कटे so in let's say in C++, you would say in immutable. Essentially what I would do, I would convert this to an array, then add that array, and I would say that if we are adding, like, every binary have two elements, so we say we can just define, if we are adding 1 and 0, we'll say that next one becomes 1, so 1 0 become a carryover, so that would be pure maths, you know. And that carry, if we are ending with 1 1, then we should add it as 1 0 again. Still trying to figure out an approach to this question. Turn their sum as a binary string. Seems like an easy question as such. Like, even if we do it via conversion logic, I have to eventually make the function to a binary. So if I have a 21 or whatever the number comes up to be, I'll have to break it down. And how will I break it down? I would start adding from 2 to the power 0, then I would say 2 to the power 1, but that would mess things up. So I need a largest power which is less than 2. Okay, so let's not go by the direct approach right now, because then I would have to reinvent how the adding works in base of 2. Right, let's go with the conversion approach. We will first convert the thing into binary, and then we will convert back it to like the system. So for this we will basically need two methods. Let's say our class conversion it will have two methods. It will have convert to binary, convert to what we say to 10 base system. We search for that 10 base system. Oh, it's just called base 10. So okay, so convert to base 10 and convert to binary. I think these it will be my conversion class. It will contain these two methods, convert to base 10 and convert to binary. Now we have convert to base 10, right? Base 10. How would we do that? That's an easy part, right? We'll take the array and we'll simply multiply it to the 2 to the power whatever it is, or we'll basically multiply it that times. So at whatever position, if it's at a, let's say we'll start iterating, I'm assuming it's an array, but how is then this be using string? But I am not using any string property here. I will be basically using it for conversion. Anyways, let's focus on solving the problem first. Later we can see what is going on. So for convert to base 10, what we will do, I'm assuming it would be an array. Okay, I will convert it to an array, I mean. So I will say for loop, I will basically run a for loop, and at each position I will multiply it, but it will give me n square, no? What the hell? Okay, so we'll use pose not equal to 0. Just say sum. Math dot pow to and whatever the number is, right? So that would give me the base 10 representation. And now if I have to convert this back to binary, what I can do is basically I will give it an integer, let's say 5 or something, and then I have to find the closest 2 to the power it can have. So I will have to find closest binary power, but then closest binary power and find closest binary power. Will we find the closest binary power to that? Maybe we can start from 0 and go up till we find, yeah, but again that would be a heavy operation. Okay, once we find the closest power, we subtract it from the current and then we find again the closest. We are not supporting negative numbers, it's always 1. Okay. Okay, let's say that we find the closest power. So we'll keep a track of sum, or maybe we can just say string buffer. It needs an answer back in a string format, string buffer. String or builder, maybe. Let's take builder. Okay, now let's say int closest pair. See, we find this. So of the file greater than 0, not exactly 0. Int can be 0. Let me just say v minus c. That's how new way. I don't know what's find closest binary power. Let's say I get 2 to the power 4. Then to break down that as well, right? That's why I'm finding the closest binary power, right? So 2 to the power 4 with the fourth position. So I will receive 4. Shouldn't we start from the 0? But then it would always stop at 0, right? So find closest power. Let's say I return 4th. So in my string builder at the 4th so I know that my string would be at least this characters long. Let's see so I know that stay out. I don't know, I still feel that I can use an array here. That would be better, because an array I can basically initialize after getting the closest power. Then I can say that we got the closest power, that was the max size of the array. Then I can just manipulate the position. So I am not able to think in terms of a string. How will I do with the string? Because like see by using array I can do it, right? If I don't use string builder, I can basically use an array, right? And after that we can basically find the closest first power. That would basically be nearest just one small power with where we cross 2 to the power 5. And I can say that in array we do that. That's the size of the array, and at each iteration I can just basically whatever position C gives me, I can put a 1 there, right? So that's they can be done with an array, but I still don't understand how to do it with a string. Okay, let's see how they are doing it, because like no point in implementing a solution which I thought of and using array when they like want it in a string. Okay, a simple way to use converter AB into integers. Compute the sum. What the heck? Okay. Okay. There's a conversion of binary string to decimal back here. Let's consider okay, number one. Yeah, that's what I thought of. Right, we can simply do an addition. And approach to is bit manipulation. Here's is there follow up here as well? Funny. Well, I will come to that afterwards, but let's see what they're doing with the carry. At the end of the day, they are also using char, right? A dot character carry, which is okay. Let's do it a classical way. I've seen what they're doing. Just will be a caret plus carry if carry modulus okay, okay, I will take a short break. Okay, just give me a moment. I'm just coming back in 5 minutes. Going to drink the water.